Hi folks, Mr. Long here. We're going to do a screencast on how to calculate the absolute maximum minimum on an interval when you're given the algebraic equation. So in the previous screencast, you saw it conceptually with a graph given. Now we don't have a graph, we just have a function. So one of the first things I think you should always do when you read this question is to look at that graph and say, is there some way that I can sketch it? Do I have a rough idea of what it looks like? And I really believe that's quite important. So if I was to look at this one, what does it look like? Well, it's a cubic and it's a positive a value, so it's probably, if I had a grid like that, I know the y-intercept is +2, so maybe the graph, I don't know for sure, goes up, comes down, and goes up again, right? That's ballpark what it might look like. It doesn't have to do that, but as a roughly a cubic graph might look like that. Okay, so so how do we go about doing this? So there's 5 steps, 5 key steps, and the first one I didn't list because that's make a graph, because you don't have to do that, but I still would encourage you to do it. So first thing we're going to do is solve f prime equal to 0 to find where we get horizontal tangents, right? So that's the first thing we do. So we start with, there's our original function right there, there's f at x. And so we have that. The derivative of that is 3 times 8, 24, reduced exponent by 1, x squared. 3 times 2, 6, minus 6x, minus 9. Now I need to solve that and set that equal to 0. Why am I setting that equal to 0? Because that's where I get horizontal tangents. That's where we get turning points, right? So what I do is I set that equal to 0. I see there's a common factor of 3. I factor that out. I'm left with 8x squared minus 2x minus 3. And I factor that or polysolve on my calculator. I don't care at this point. So when I do that, I get x equals 3/4 and x equals -1/2. Those, folks, are the critical values, okay? And they can be stationary points. It means the same thing in this case as a stationary point. So it looks like 3/4. So I got like 3/4 is there, and then I got -1/2. Well, maybe that's up there, right? So it should be based on, see, this is where the shape of the graph is important, because it allows me kind of to verify my work. So the first maximum, or the first critical value I hit should be a maximum. The second one should be a minimum if I've done it right, right? Because I know from advanced functions that's what the cubic will look like. So furthest to the left should be a minimum at -1/2, a local minimum. So, or sorry, a local maximum. The first one should be a local maximum. So what do I do now? Now I get the y values, okay, at those critical points. And actually, before I do that, I guess I should have, yeah, I should get the y values. You know what, folks? You know what? The table should be set up first. So let's do that. Let's set up the table, and then that'll be filling it in, right? So let's do this. I'm going to take this and bring, oh, I can't bring that up here. Okay, well, you know what? I'm going to change the order of that afterwards, but it, again, doesn't really matter. So let's get the y values at the critical points. So what I do is I substitute in 3/4 into this right here. So actually, before I start, I should put the x values in my table. I'm really sorry about this, guys. So what are my x values that I'm interested in? Well, furthest to the left is -1. That's the first entry into my table. Then the second entry should be the furthest to the left critical value, which is -1/2. If I have any other critical values, I should put them in and go to the right. So 3/4 is to the right of that. Finally, the last x value that I need is my right endpoint. Okay, so again, left endpoint and then critical values in sequence, left to right. All right, and we're ending up with that. Now what I do is I get my corresponding y values. Substitute in -1 into the original formula. You get 0. Substitute in -1/2 into the original formula here, and you get 4.75. Substitute in 3/4 into the original formula up here, and you're going to get -3.0625. Substitute in x equals 2 into the original formula, and you get 36. Now what I do is I analyze my table. Okay, I analyze my table. What do? I go in and I identify where's the maximum, where's the minimum. 0, 4.75, negative 3.06, 36. It's pretty clear that my local minimum, my absolute minimum is negative 3.06. My absolute maximum is 36. Now I make a conclusion. And by the way, did it make sense? So that first, when going left to the right, I should have had a local maximum at negative 1/2. 4.75. Yeah, it was. Then I should have had a minimum here at negative 3.06. In fact, I did. Right? And then it went way up to the right at the right endpoint. Okay? So if I look, I've got the absolute maximum is 3.6, or 36 rather. That's right here. When x equals 2. Do I have to add that? No. Now that's why this is underlined, because that's really answering your question. I really like to add on when x equals. Some people don't, but I like to. And then there's an absolute minimum for f is negative 3.06 when x is 3/4. Okay, folks. So again, scratch this sequencing here. I don't think through that very carefully. First thing is true though, definitely. F prime equals 0. Solve that. And as soon as you do that, you can then put your values, the x values, in your table. Okay? You can put your x values in your table. So far left endpoint, then you put left, going left to right, any critical values, or what are called stationary points. That's for when f prime is 0. And then you put in the right the right of the interval, and then you get all of the corresponding y values by subbing into the original equation, and then you scan through your table and identify your absolute minimum and your absolute maximum. Then you make a conclusion, and you're done. Okay, folks, so we're going to start with that and use polynomial equations that you're familiar with, and then at other times later on, we're going to use different families of functions. So maybe it'll be radical, maybe it'll be trig, maybe it'll be ln, maybe it'll be exponential, but the process is always the same.